Hi, and welcome to this look at how to balance a chemical equation. This is aimed at sort of the very beginning of the A-level chemistry course. So we're going to look at an example of a metal oxide reacting with an acid. So I'll take you through the stages of recall, how you construct the formula, how you then balance it, so you then have everything in place. So the question says, write a balanced equation for the reaction between aluminium oxide and sulfuric acid. So going back to our ion list, we need to look at what the common acids are, and from recall, ultimately we need to be able to remember that sulfuric acid is H2SO4. Looking at the cations and anions that we need to eventually be able to recall, aluminium is Al3+, oxide is O2-, sulfate SO42-. So you can use the common ion and formula list to start you off, but eventually by the end of the course you'll need to be able to draw upon your own recall to know these formulae to make the formula of the compounds. So you start off by recalling how a metal oxide and an acid will react to make a metal salt and water, and then you apply that to the question. So you take your metal oxide to mean aluminium oxide and your acid to mean sulfuric acid. So that will obviously make aluminium sulfate plus water. So you then have to convert your word equation to a symbol equation. So I'm going to show you how the formulae were put together. So going back to our ions list, we're using aluminium as Al3+, oxide as O2-, and sulfate as SO42-. So what we're trying to do is make those charges on those ions balance out. So you have to multiply up each ion until that happens. So 2 Al3+'s will be balanced by 3 times O2-. And in the same way, with aluminium sulfate, 2 Al3+'s will be balanced with 3 times SO42-. So what's going on in both cases is the common charge multiple is 6. So 2 times Al3+ makes 6+, 3 times O2- makes 6-, and so on and so forth. Now we have to balance it out. So we've already put in 3 sulfates on the right-hand side. So you need to put 3 sulfates in front of the species on the left-hand side that contains SO4. So that's going to mean 3 H2SO4. That now needs 3 hydrogen, 3 times H2, sorry, on the right-hand side. So 6 hydrogens on the left, 6 hydrogens on the right. So we need 3 H2Os like that to balance it on the right-hand side. So that gives us our answer. So we can double check, are the species balanced? Yes. Are the charges on the ions balanced? Well, we would have had to do that to come up with those formulae. So yes, and we're there. Happy days. Okay, thanks for listening. Until next time, see you soon.